Okay, so here we're going to do vectors. A vector is represented geometrically by a directed line segment or arrow diagram that shows both magnitude and direction. From physics, you should know that magnitude represents a length and direction is going to be your angle. Consider the directed line segment with an initial point A. So here I have an initial point A, also known as the tail, and terminal point B, also known as the head. So a directed line segment means that I have a line from A to B, and it's got a direction, so that's what the arrow is. And I'm going to label this as little a. So here, this is saying that I could denote the vector as either A, B, because I've got a capital A, capital B, so it's going from A to B with an arrow indicating that I'm going in this direction, starting at A, going to B. I've got little a, because that's the label for my segment, or I could bold my A. A bolded letter represents a vector as well. Okay. If a vector has its initial point at the origin, it is in standard position. The direction of a vector is the directed angle between the vector and the horizontal line that can be used to represent the positive x-axis. So this is no different than what we did when we were doing angles. And we had the coordinate points, and we said, hey, I've got this right here as my angle. And you would do a measurement from here to here. But instead of having the x-axis also be part of the angle, here we just have just the vector. So this one right here, I could say, let's just call this 120 degrees. And I could give it a magnitude of 5. So that means that from start to finish, it's 5 for my magnitude. So my length is 5. And I'm going 120 degrees. So that's what a vector has. It has a direction and a length. Here, component form. Components are something that make up something else. So component form is just saying, what are the things that make up this vector? So if I was to have any vector, I'm going to take right here my initial point A with coordinate point x1 and y1, and my terminal point B with x2 and y2. I'm going to find its horizontal change by taking, hey, where did I end? Subtract the beginning for both the x-coordinate and the y-coordinate. And that's going to get me my change in my horizontal value and my vertical value. So right here, to find the component form of vector AB with initial point A at -4, 2 and terminal point B at 3, -5. So the initial point is going to be x1, y1. The terminal point is going to be x2, y2. And so I have to go ahead, write it with these little brackets. I have one of these on each end of it because that gives me component form. That's what that represents. So I'm going to do 3 minus -4, and then -5 minus 2. So now I'm going to go ahead and simplify this. So 3 minus -4, well, that becomes 3 plus 4, so I have 7. And -5 minus 2, that's going to give me -7. So this is saying that my vector, if I start at this point A and I end at this point B, it's telling me horizontally I go right 7, and vertically I go down 7. Let's confirm that by graphing it. So right here, I can go -4, 2. So 1, 2, 3, 4, 1, 2. So I'm here at -4, 2. And then I'm going to go to 3, -5. So 1, 2, 3, and then 1, 2, 3, 4, 5. So let me connect the two of those. Right there. So now, from, well, let's do it this way. Let me do it this way. From here, I'm going to go horizontally. Oh, that is a really big. I'm going to try a different one. Oh, those are all going to be really thick. Okay, I'll just drop it. I would go horizontally from start. And I'd go here. I'd go 1, 2, 3, 4, 5, 6, 7. Hey, that's just what I said. I'm going to go right 7 and then down 1, 2, 3, 4, 5, 6, 7. Down 7. And that gets me from this point to this point, telling me how far I changed horizontally and how far I changed vertically. So that's how the vector components are brought out. That's what that is. So let me try this one right here. I'm going to find component form of this one. This is telling me I'm starting here. So this is x1 and y1, and this is x2 and y2 because this is where I'm ending. So I'm going to go ahead and go. I've got my end. I'm subtracting my beginning, 6 minus negative 2. And again, I've got my end, and I'm going to subtract my beginning, 1 minus negative 7. So 6 minus negative 2 becomes 8, and 1 minus negative 7 also becomes 8. So likewise, if I was to graph this like I just did before, this would tell me that I'd be going right 8 and up 8. Now it's important that I do it with going in the correct direction, where if I start at my initial and I end at my terminal like this, if I go in this direction right here, because that's telling me I'm going right and I'm going down. If you think about it, if I'm starting up here and I've got to end down here, that tells me I'm going to have to go down. If I went the other way, if I started here and I went up, well, obviously I just said I'm going up, so that means I'm going to be going vertically positive. So that means I'm going to go I'm going to go left 7 and up 7. So that means that I would have negative 7 and positive 7 here. So that's why it's important I go in the correct direction and I use the terminal point correctly and the initial point correctly. So if I was to take this instead and call this x2, y2, and this x1 and this y1, then I would get, that's where I would get negative 7 and 7, which would be wrong. This is what I need. So I need to make sure I go in the correct direction. So I need to pay attention to what the initial point is and what the terminal point is. Oops. All right, so I'm going to do magnitude. Magnitude is the length. Well, hey, if we look at this right here, if I was to figure out what the length of my vector was, I could do something I'm very familiar with already. I could do Pythagorean theorem because this is a right triangle and I have the length of two sides. I have my A, I have my B, so I can figure out what C is. So let me do that really quick. If I'm going to do that, that would be 7 squared plus negative 7 squared equals C squared. Okay, so that gets me 49 plus 49 equals C squared. So now I have 98 equals C squared. If I solve for C, I get C equals the square root of 98. The square root of 98 reduces, that's the square root of 49 times the square root of 2, which the square root of 49 is 7. So I have 7 square root 2. So that's what I have right here, 7 square root 2. That is my magnitude. That's telling my length from start to finish. I'm going 7 square root 2. That's the length. Okay. Same thing right here. So what I just did was this. This is just a squared plus b squared equals c squared. Instead of being c squared, it's just solve for c. So I square root both sides. That's all that is right there. And that's if it's already in component form. If it's not already in component form, I'm going to find component form while doing this. So here I have initial point A. So again, x1, y1, and terminal point B, x2, y2. And I'm going to go ahead and put it into this equation. It's the distance formula. So I'm going to do 3 minus negative 4 squared plus negative 5 minus 2 squared. So that gives me the square root of 3 minus negative 4 is 7 squared. Negative 5 minus 2 is going to get me negative 7 squared. Hey, doesn't this look familiar? That looks just like what we just did right here. That's exactly what I'm doing. You're going to get the same answer either way. So here's 49 plus 49, which we already figured out. That's going to get me the square root of 98, which is 7 square root 2. So either way, you're going to get the same thing. It's just you can do one if you're given points, and you can do the other equation if you're already given component form. Right, this one right here. I'm given coordinate points. I'm not given component forms, so I'm going to have to use the formula that I just did. This is my initial point, so this is x1, y1. This is my terminal point, so this is x2, y2. And I'm going to go ahead, put it into this equation, where I'm going to go x2 minus x1 squared plus y2 minus y1 squared. And then I'm going to solve. So now I have 9 minus 0, which is 9 squared. Negative 3 minus 8 is going to get me a negative 11 squared. So now I have 81 plus 121, which this gets me 202. So the square root of 202, I cannot reduce that. That's just my answer. So my magnitude, denoted as this, I have either 1 bar, sometimes you'll see 2 bars, it just depends upon the book you're looking at. So you'll see either 1 or 2. It's just saying the absolute value of AB is the square root of 202. Okay? All right, so I don't have time to finish this, so I'm going to do the operations in another video.